Okay, we're going to do 2.2 review problems. And they start with the following. Of these three equations in y and x, which of them represent functions of x? Now a function gives you one y value for each x value you input. We look at y equal absolute value of x. When we put an x value in, we get an answer for y, and only one answer. So that's a yes, it is a function. Our second equation, y equal plus or minus x, when we plug in an x value, like 4 for instance, we get y equal plus 4 or minus 4. Two answers, so the answer here is no. Now the third one, y equals the absolute value of x squared. A little trickier. If x is 2, y is absolute value of 2 squared, which is 4. If x is negative 2, we also get 4, but it's still a function because each x results in only one answer for y. So it is a function. So the answer is yes. In our next problem, we're given f of x is x squared minus 2x, and we want to evaluate and simplify f of x minus 2. So here we replace each x, and there's two places where x occurs, in that function with the quantity x minus 2. And then we just simplify the result. So when we do that, we get x minus 2 quantity squared minus 2 times the quantity x minus 2. Because the function is to square whatever's in those parentheses and subtract 2 times whatever's in those parentheses. So when we simplify this, we just square out the x minus 2 times x minus 2 minus 2x, and that's going to be plus 4 because it's negative 2 times negative 2. Then FOIL out x squared minus 2x plus 4. Now we combine like terms. X squared minus 6x is plus 8. Okay, let's look at this topic of domain. For each of these two functions here, find the domain. Or and I'll squeeze one more example in at the bottom here. Find the domain of f of x equal 1 over x plus 3. Well, negative 3 gives you division by 0, so the domain is all reals except x equal 3, negative 3. Okay, in our next problem, which proves to be a bit confusing for a lot of people, we have this two-part function. F of x equals x plus 1 quantity squared if x is greater than or equal to 0, and it equals 2x minus 1 if x is less than 0. So what it's saying here is if the input value, x, is greater than or equal to 0, we use the top formula. If the input value x is less than 0, we use the bottom formula. So here we're going to find f of a minus 1. where a is greater than 1. So for f of a minus 1, where a is greater than 1, our input here is a minus 1. We know that a is greater than 1. If we subtract 1 from both sides, a minus 1 is greater than 1 minus 1, which is 0. So we get a minus 1 is greater than 0. So the input value is greater than 0. So we use the top formula. So we use the top formula and we plug a minus 1 into the top formula. So when we plug a minus 1 in for the x of the top formula, we get a minus 1 plus 1, because the formula is to add 1 to the input value and square. Well, a minus 1 plus 1 is just a, and then we square it, and our answer is a squared. Now we move to the second problem. In the second problem, the input is a minus a half. Since a is less than 0, if we subtract a half from both sides, we get that a minus a half has to be less than negative a half, which is less than 0. So our input here is negative. A is negative. Subtracting a half from a makes it even more negative. We use this second formula. And in the second formula, we're replacing x in the formula with a minus a half. We double the a minus a half, which when we distribute gives us 2a minus 1. And then we're subtracting 1 from that. 2a minus 1 minus another 1 is 2a minus 2. So we have to look at the input values, what's in these parentheses, to see which formula to use. Once we determine the formula, we plug that input value in for the x of the formula and evaluate. Okay, we're going to do another problem. Evaluating functions. Given f of x equal 1 over absolute value of 4x, find these different expressions where we evaluate the function at x equal 1, negative 2/3, f of negative 2/3, f of a squared plus 1, f of 3 plus k. So for our first problem, we plug in 1 for x, and we get 1 over absolute value 4 times 1, which is 1 over absolute value of 4. Well, we don't need the absolute value. We can just write that as 1/4. Okay. Okay, in our second part, we replace x with negative 2/3, plugging it into our function. We get 1 over 4, absolute value 4 times negative 2/3, which is 1 over absolute value of negative 8/3. Well, that negative turns positive because we're doing the absolute value. We invert and multiply, and we get positive 3/8. Okay, in our third part here, we replace x in the formula with a squared plus 1. So we have to distribute, multiply 4 times a squared plus 1. We get 1 over the absolute value of 4a squared plus 4. And the question is, can we drop the absolute value bars? Well, if we know that 4a squared plus 4 is positive, we can. Well, a squared is always positive. So 4 times a positive plus a positive is going to be positive. So since we know the denominator is positive, we can drop the absolute value bars. So the simplified answer is just 1 over 4a squared plus 4. Okay, and in our final part, we're plugging 3 plus k in for x. And when we do that, we get 1 over absolute value of 4 times 3 plus k. When we distribute it, it's 1 over 12 plus 4k in absolute value bars. Can we drop these absolute value bars? We could on all the other three parts, but what about this one? What if k is -4? You're going to get a different answer than if k is +4. We don't know if the bottom is positive or negative. So if we dropped those absolute value bars and k was -4, we'd get 1/12 minus 16, 1/4. We'd get a negative answer. But this answer has to be positive because it's 1 divided by this absolute value bar. So to keep the answer positive, we have to keep those absolute value bars. We don't know if that quantity is going to be positive or negative inside that, the absolute value bars. So they have to stay. Okay, and that's it for the 2.2 review.